Hi everyone. Good afternoon. Yeah, good afternoon. Yeah, good afternoon. Yeah. I would like to think of this as a classroom or as a lecture room, whatever. Yeah. The name is Samuel Abada. GD Flutter. That point of correction. I'm no longer in short class, please. I'm no longer in short class. So, very important. All right. The topic says the data analyzer plugin system. So, are we all Flutter engineers? I write Flutter high. That's nice. So, by extension, you write that. Okay. I don't write Flutter high. I don't write that high. Okay. If you are not a dev, please leave this classroom. All right, just kidding. I write JavaScript high. Okay, of course. Python high. Of course. Mileke, what do you write? You were writing Python just now. I said Python high. You just, uh-huh. Thank you. All right. Some table of contents, just long story and blah, blah, blah. For the ops not to have me today, right, this presentation is available via this URL and this QR code, so you can follow along with it, right? So that's one way to beat the ops. Yeah. So you could scan that or visit that URL to have this. All right. This is a sample from some code base with a lot of problems, linked problems. But no matter what you write JavaScript, you write that, you have Python, there's some form of linting, right? AB, flakate, black, ESLint, and for all that lint, right? So you would always face lint issues, right? Or you work with lints, right, to maintain consistent style in your code base. So this is what lint problems look like in that lab. So this VS Code, this is some developer, right, and these are lint problems. Don't use build context across async gaps. A lot of those errors here. This person does not say year word, but it's fine. Right. So these are example of what lint issues would look like. So typically, we all have that developer in the team, right, that always notice everything. So you send a pull request, and it tells you, use arrow functions here. Don't use method body, right? Or it tells you, oh, you could have kept everything on one line, right? Why do you take it over two lines, right? Those that notice even the smallest of issues, and you're like, this does not mean, I mean, the code compiles, the code is going to work. Why are you stressing me, right? Yeah. You might be that developer, like me, I'm that person. I would always point out those little things because they matter eventually, right? Yeah. So to enforce these rules, consistent style and system across code base, right? We do what we call lint rules. So in that, you add some lint rules. Python, you add some lint rules. JavaScript, you add some lint rules, right? And you expect that everybody adhere to those rules, right? Anybody that flaunts any of these rules, their code does not get merged in, right? Their pull request just stays there until they attend to those rules, right? At the point of these rules are to ensure consistent code style across board. So code written by me, written by Mileke or Jamil or Miracle, as long as we are in the same organization, writing same code, same product, right? It should not be distinguishable. The code style is the same across board. That's the point of the linting system, right? All right. However, I think there seems to be some problems, right, in the data ecosystem with how lint works, right? And let me give my own experience. So I manage a monorepo, right, that contains a lot of packages and applications, right? I use, if I say what I use now, the I'm flexing, but I use a MacBook M3 Pro, right, 18 gig RAM. However, the code base does not respond as fast as my hand can move, right? So I've typed autocomplete, I've not done the completing. I want to jump to definition, right? My ID can't just follow, and I'm frustrated. I'm shouting, "Ah, guy, please be fast now, right? What's the problem with this? It all boils down to one thing: the DAT analyzer, right? People that say the DAT analyzer is slow. Oftentimes you may not experience it, but me, I always experience it because the kind of project I manage, right? So I can tell that this guy is slow. Now some people say, oh, let's rewrite the analyzer in Rust. Please, don't do that here. I mean, that's how they crashed, is it Cloudflare now, actually, some days ago. But it's fine. Yeah. So the that same, having looked at all this, right, and people find it hard to also write their own custom lint rule because the current analysis server plugin it's a lot of information to understand. It's not beginner friendly, right? And I think the people at Invertase came up with a custom lints, right, to help you easily write your own lint rule. I mean, and that has been working for us. But even for me, that still managed by monorepo, I still have problem with custom lints, right? I still have to run some command to run the lints, and at times, before the lint will kick in, even on my 18 gig RAM, how about the guy using 8 gig RAM laptop? That guy will be crying. So the Flutter team says, okay, you know what? We've had your complaints and your cries, right? And then they introduced a new plugin system, right, which is currently in beta, right? And they call it the new DAT analysis server plugin system. So what is this system all about? It's an improved way over how the analysis server currently works. An improved way on how to write custom links, right? Performance better compared to the previous one, right? At least projects that have been using it, I'm enjoying the project. I'm not crying, right? They focus on a couple of things. The reason for the new plugin system is one, the old system consumes so much memory. When you check your activity monitor and you see how much it's using, like it's consuming resource a lot. The old plugin system has a complex API. The learning curve is steep. It's not beginner friendly. Not just anybody can pick that up and work with it. That's why things like custom links exist. However, the new plugin system promises better performance, right? Instead of using separate process per plugin, as the current system does, which is why it consumes a lot, each process its own, each plugin its own process. You have a shared isolate, just one single isolate. Isolates are that way of working with threading, right? Threads, multi-threading, and whatnot. Yeah. So the new system proposes a shared memory, single isolate, and a very simple API that just anybody can work with. And that's what we're going to cover today: how to work with this. So what does the beta offer? By beta, I mean the DAT Analyzer plugin system, the new one, which is in beta. Three things. It offers you a way to report diagnostics, basically warnings. It offers you quick fixes for these warnings. And it offers you assist. So on your editor, those small light bulb that you can click on to do maybe wrap with container or, and others, extract widgets and whatnot, right? Those are assists. So the new plugin system gives you a way to write those also. So today's journey, let's look at how to write simple links in the new plugin system. All right, the repository for this session is also available over the internet. I think this is it. You could scan the QR code. You could also do that. If you have the slides, it's in there in the slides. All right. Without further ado, let's go to the business of the day. Not too much English language. So setting up your plugin project, you create a very simple DAT package, right? Package this time, not plugin, right? Your dependencies basically is the analysis server plugin, the analyzer itself, the analyzer plugin, then every other thing is just miscellaneous, like the collection package. Of course, analyzer testing for writing tests, then the test reflexive loader. So this is basically what all you need to get started with writing simple lint rules. The next thing is to bootstrap the plugin. So let's go into this is a combination of lints that I've written. Take all this out. So what we have here, let me see if I think I should zoom in a bit. So yeah, this is what it all looks like. I've been bootstrapped, right? Whatever lints plugin you are building, you extend the plugin class. The plugin has a name, right? So you override the name, property, got some lints plugin, and then a register where you register your assist, your fixes, and then the lint rule itself. All right, let's proceed. So how do we write a lint rule? How do we declare this analysis rule? Let's jump in here. So all lint rules have basic syntax, or what they look like. I mean, all the skeleton looks like. The very first thing, you want to extend the analysis rule. So in my case, I'm writing a lint rule for those people that like having files with 1,000 lines of code and whatnot, right? So my lint rule here is for file length limit. And it's meant to scream, the file is too long. Please split into smaller files, right? The very first thing here is you extend the analysis rule class. Then you override the diagnostic code method. In that case, you define the lint code, which takes in the name, the problem message, the correction message itself, and the severity of the lint. Is it info? Is it warning? The severity itself is what is it? You could do it, no severity. It could be info, warning, error, whatever the case may be. In my own case, I'm leaving it as the default, which is just info, right? And then the most important bit here is registering the node processor. So that's where all the magic happens. Whatever name you're giving the lint through, whatever class you're calling it, eventually what's going to happen is the analysis logging system is going to check the node processor, right? To see how it's going to act. So in my own case, I have a very simple class that is meant to traverse the AST tree, right? And then count the lines of code you have in that tree. So in this case, it's a file, right? So how many lines of code do we have in the file? So here, I've said my max line is 500 lines. Where the line count is more than 500, I want to report the rule as that node because you've exceeded the maximum lines of code. So that's how you write a simple rule. First things first, you want to extend the analysis rule, its class, that's one. You want to define the lint code and override the diagnostic code property or getter. Then you want to register a node processor. That's how the structure of a basic lint looks like. The AST visitor itself. So after writing this lint, it does not end there. The next thing is you want to activate this lint. You want to load these lints in your ID. You want the ID to see them as information that it can toy with and play with. So how do you do this? In my case, we created a plugin that we called Gotham Lints, right? That is meant to help us clean up Gotham. So if I have an example project here where I have installed got some lints here from parts because I have the lints library locally. The next thing is typically all lints in your data plotter project are registered in the analysis options YAML. So in my case, I already have the recommended lints from the Flutter team and the DAX team. The next thing is, since I'm dealing with a lints plugin called Got Some Lints, I want to register Got Some Lints. This can be found at this part. Then I have this diagnostics rule. In this case, what we're doing is just file length limits, right? So that's this being registered. Then you can enable and disable it, boolean true or false, right? So this is basically we activating the lints rule. This is we registering the lints plugin itself, right? So in this way, that Flutter your ID is able to recognize these links, and then of course throw problems right there your ID. So things like you would have so those that violate this rule, right? So we have them as problems down here in the problem tab. Right, so yes. So that's how you activate a lints rule and enable the analysis plugin. So oftentimes your rule may come with fixes. There are rules that may have fix. There are some that may not have fix. It's not in all cases. If your rule is going to have a fix, how do you write this fix? Now this fix is not. This fix is written by the engineer that came up with the rule. You write the rule. You think the rule has a fix, right? So you write the fix for the rule, so that whoever violates that rule can apply the fix. Right, so how do you write a fix? So I'll go through a random fix that I have here. So let's see. Eventually, it doesn't matter. Let me just use this. Yeah. Let me use this. All right, so yeah, I have a very simple fix. So yeah, I have this fix is meant to be applied to a lints rule where I want to prefer integer division over that kind of division. Syntactically, it's the following steps. One, you want to extend the correction producer itself. It's a fix. You are correcting something, right? So syntactically, you want to extend the correction producer. That's one. For lints, you define the lints code, but here you want to define the fix kind, right? So the idea of the fix, the priority to give it. In our case, it's a standard fix. So of course, standard, inline, or you want to ignore, right? They have different priority level. Then the message, right, for this fix, the message. So in my case, it says replace with, and that's integer division symbol, right? You also want to tell where this fix can be applied. Should it be applied across the file or a single location? It's also an enum, as you can see, so single location across the whole file or across multiple files. Should it be applied automatically? Should it be applied automatically but just once per file, right? So you have to tell the system how to apply this fix. So in my case, I'm like, oh, please just apply this fix in a single location. Don't bother going through the code base, right? So you override the fix kind getter also and point it to our fix kind that defined earlier. And then the magic itself, where the fix happens, is there in the compute method, right? So here I've tried to get the node. The node here is basically where that rule was violated, right? So I'm getting the node. I have a change builder where I'm going to add the that file fix, right? And all I'm doing is a simple replacement. Prefer integer division, right? So find the line that defaulted the rule, right? Or the block that defaulted the rule, then replace it with the integer division. So that's what I have here. So add simple replacements through the range of items in the file at the node where it is defaulted, replace that bit with this, right? So that's how to write a simple fix, right? You want to extend the correction producer. You want to tell it how to apply the fix. You also want to write the magic behind applying the fix itself, which is the compute method, right? So that's how we do that. But it does not end there. Now we have the rule, we have the fix, right? We are going somewhere. So the next thing is to register the fix with diagnosis, right? Basically telling your ID or the system that, oh, this fix is for this rule. So you should be able to find this fix. So how do we do that? Similar to how we register our lint rule. So let me take all of this out so it's easy to compare. And then take all of this out so it's easy to compare. So yeah, we have register warning rule. So this first line basically is a lint rule. So we are registering the lint rule here, right? So you register the warning rule, whatever class we've defined earlier. Then for fixes, register fix for rule, right? So in that case, whatever fix we had defined, in this case, this is the lint, right? So we register the lint, then beside it, the rule itself, which is this. This is another lint rule that we have here, right? So the method basically takes in the generator for the fix, and then the lint rule itself. So we have the lint rule and then the fix, the lint rule and the fix. For assist also, you register the assist itself, and then for lint rule, just register the rule class and the warning rule. Warning rule and lint rule are very, very similar, right? The difference is just that warning are basically warnings. For upper lint rule, you can tell the severity property. Is it an error? Is it an information? Right? But for the warning rule, it's just warning only. So that's how we register fixes and warnings. Right? I will show how they work eventually. So no need to panic. Okay. All right. So yeah. So the next thing is assist, right? Yes, assist. Yeah. So the justice funds in the house, sorry, an assist. All right. Yeah. So how do we work with assist? Assists are very close to fixes, because you flaunted the rule. You need a fix for the rule, right? So you are trying to assist yourself, right? Exactly. So you are just doing the tapping. The ID is doing the assist. All right. You extend the correction producer, very similar. You extend the correction producer, but this time, right, it's an assist kind. So for lints, we had lint code. For fixes, we had fix kind. Yes, we had fix kind. Then for assist, we have assist kind. I don't have an assist here in my ID. I'll show us what it looks like. But yes, we have an assist kind. So similarly, you define how it's going to be applied. Single location, across file, across multiple files. Applied automatically or applied automatically but once per file. You define that. You override the assist kind. And where the magic happens, the compute method, that's where all the magic of making the fix happens. When you look at this, it's very similar to the fix that we had. Our fix basically replaced a particular line of code with another line, right? In this case, we are basically deleting some line of code. So assist and fix are very similar in how they operate. All right. So how does that work in practice? Let me zoom out a bit. So I have an example project here, and I have a couple of lint rules I've written. So let's see how they work. So this is the example project. I have installed Gotham lints, right? And then I've enabled a couple of the lints that we've written. Things like use sizebox instead of container, feature without async await, preferring list view builder, unnecessary opacity widgets, avoid deeply nested widgets. Yes, I mean, it's a widget tree, but please help us. Yeah, file length limits, not exporting from SRC folder, and all those other lint rules. So let's see. The first thing first. Our problem tabs. So these are problem tabs with a lot of problems. So this engineer has, I don't know, has flaunted a whole lot of problems. So we can see some of them. Use integer division for explicitly cast to a double, or yes, that's that. You can see some like future returning function should use async or handle the function. You have some like a feature is not awaited or explicitly handled. We have some like the file is too long, please consider it into smaller files, right? So these are discovered by the IDE because we now have these lint rules enabled and it works like real time, right? So so this is a very long class, right? I don't know how many lines of code is here, but let's see. Yeah, we've got 508 or 9 lines of code, and then the idea is to us, without the lint rule working, file is too long. Consider splitting into smaller files. A factor the file to be shorter. And that came from the lint rule that we have earlier, defined in here, which is file length limits, right? So why 500? Because we defined that 500 lines of code, right? So it begs the question, can we dynamically define how many lines of code we want this rule to apply to instead of hard coding it there in the code? I would come back to that. So yes, this engineer has written a very simple API service, and everything violates a lot of rules. Feature without async await. I mean, who wrote this now? Come on. I know I wrote it, but I mean. Since we have fix and assist, right? So quick fix, will this work? If it does not work, more bugs. It works. Yeah, it works. Right. So what happened there? Let me undo it. Right. It says the function returns a feature but does not use async. Right. So when we go there, there's a quick fix for it, as we've written earlier. Apply async keyword. The error is gone. Right. Similarly, same thing. Same thing. So like that's about that. Very long file. We did not write a fix for this because how are you going to help someone to break the file themselves, right? So the engineer would have to come and break their file themselves. It's not my problem. It's for the person that wrote this that will do it. But in the end, I wrote it, so I mean, well, yeah, that's that. Let's see other problems that we have. Similarly, apply, let's see. Oh, okay. All right. Let's go through. Then of course, I also have some nice lint rule that I think I would like to apply everywhere. So I think this rule is for Yes, enforcing immutability on models. I want my models to be fine now. If I've defined the user model, everything should be fine now. I don't want anybody to just be changing the property of the class anyhow, right? So I wrote a very simple rule for that. And that's what is responsible for, I think that was responsible for this file being flagged, right? So you see a user model, and I have name, I have age, I have email, but they're not final, right? So yes, that's what caused it. So you see, it says model field should be final for predictable states. Add final to the field declaration, right? So yeah, I don't have a quick fix for that, right? But yes, that's how it works. And then you see it here. Similarly, model field should be final for predictable states. Add final to the field declaration. So that's how this works. Right? Yeah. Prefer using sidebox for simple sizing over container. We also have a lint rule for that written here, so you can just replace it. Right. So this is basically the quick fix that we've written. Doing the same. Right. So yes. Of course, you could also decide to ignore. Yeah, so that's basically how the lint rule works and how applying the fix works. Let's see. I think I also have another lint rule for hard coding colors and styles. I don't want anybody to be styling their components in line, right? So I wrote another lint rule for that. So yes, please don't do this. Go and find how to do it, right? So yes, more lints, more violations, more violations, more violations. Yes, so this is an example of a deeply nested widget, right? So for me, in the lint rule, I think I defined that any widget that has gone beyond 8 levels of nesting is deeply nested, right? So this is the rule here. Very simple. Extend the analysis rule itself, define the lint code, then register the node processors, right? So in my case, I have just traversed the AST tree, and I said, yo, maximum depth at 7, look for where you have child or children, or you have a list literal. That's like you have a list of widgets, typically, right? And if then traverse this, then increase the depth. So we start from 0, go to, you found one child, depth is 1, and that child, that and that depth, and that child and that depth. Or you find children, or you find the list of widgets, keep increasing the depth by 1 until it's better than the maximum depth defined, which is 7, right? And when you do that, report the rule at that node, right? So that's how we know that, oh, you've broken the rule here, right? Yes, of course. So that's how that rule works. And then, what file are we in now again? I can't remember. Yeah. So yes, so that's how, we arrived at this nested get. So when you look at it, yeah, avoid deeply nested trees for better readability. Consider extracting a new widget from this portion of the tree. So when you look at the number of children that we have, you can tell that we've gotten, 1, 2, 3, 4, 5, 6, 7. Yeah, so 1, 2, 3, 4, 5, 6, 7. Yeah, so after the 7th one, start shouting. Right, so this is a deeply nested tree. It's a tree now, but this tree don't displant already. But yes, that's another lint rule, right? And yeah, lots of ways you could use them. But are they the next best thing after this sliced bread now? I don't know. So what are the current limitations of the new plugin system? Let's not forget that initially I said this is a beta release, right? So 1, user configurations are not possible. What do I mean by user configurations? When I showed us the links earlier where we defined how many lines of code you need to have gone through before you say the file length is too long, I use 500 hard-coded, right? I think I had used 500 hard-coded, which is, yeah, I think this is it. So I had hard-coded is 500. However, there is no way I can dynamically define the maximum lines here. So a case where you want to use Gotham lints in your projects now, right? And you want to use this lints rule, or you want your maximum lines to be like maybe 800 or thereabouts. That's a limitation. You can't define that outside of the source code itself, right? That's one limitation. 2, you have missing type checker, right? I know in that we talk about type safety all the time. When I say missing type checker, things like, let me see a simple rule where I could show us. Let's see. Where's that nested? Yes, so I mean I had to like do string comparison here, right? Look for the parents, is it a name expression? Check if the parent label has child or has children, right? So it's the type checking here is shaky. It works, yes, it works. But I mean it could have been better, right? That's another limitation. And thirdly, it's still in beta, meaning while the API surface is simple to use, right? It might change in the future. I think the very first time I started playing with the new plugin system, there were no assists. That's one. And then the code does not look like this. It looked a bit different from this. So yes, it's still in beta, so meaning it could change before it becomes stable. All right, yeah. So how do you contribute to the beta program? I think there's an open issue there on GitHub. Yeah. The new analyzer plugin system basically shows you everything the DAT team wants to cover, what they've covered, what they've not covered, and how you can contribute. Are you using the new plugin system and you have issues, you have feedbacks, you want to request things, right? I mean, this issue documents everything. I mean, yes, document everything, and you can find people there and whatnot, right? Yes, so typically the kind of issues the DAT team is looking for are issues around missing features. For example, having to configure the lints rule, right? There's still gap with documentation right now because all the documentation exists inside the SRC, and maybe some README files from the analyzer plugin itself. And of course, robustness issues, you want to cover a lot of cases, right? So these are the kind of issues the team is looking for feedback on. So yeah. What else? Yes, so these are some repos that you could look out. Again, I would show the QR code so you could scan this eventually. The test package from the DAT team has they're trying to migrate to the analysis plugin system, right? So you will find a lot of code that you can learn from. The popular Mockito plugin for mocking, right, and faking stuffs, right, also has that. You can also check the repo. This project exists also, got some links on GitHub, right? So you could get it from there. Right, so again, the slides are available here. Yeah, that's the QR code and that's the link. So yeah, thank you. Any question? Yeah.
Hi everyone. So are there any questions for our speaker?
Oh, okay.
I'd like to ask you questions.
We have questions. We have questions, yeah.
Where are the ushers?
Yeah, so when describing the type of fixes,
Yes.
You mentioned the automatic mode.
Yes.
Does that mean when you save, it automatically apply the fix, or what is that supposed
Yes, so
to?
the automatic mode basically is when you save and it finds that link, right? it automatically fixes itself.
Okay.
That's the automatic mode, yes.
Then build runner should.
Huh?
Oh, okay. That
So
makes sense.
I personally I'm excited for the new system because it's a lot of
Mhm.
there's a lot of things you can do with it. Lint is just like I know Lint might be the main use case, right? But there are other crazy
Yeah,
uses that
that's
we've seen on Twitter recently. Yes, but that's the point of automatic mode, right? You find this or you save or you found this rule. It's us if one fix exists, automatically apply the fix. It can be automatically applied across or once per file, right? Once per file meaning in case there are more than one instances of that rule violated in the file, right? So you could tell it, oh, once you found this just once, just fix that one only, right? Or just fix it across the file. Yes.
Yeah. Thanks. One other question.
Okay.
The analysis rule, I saw that you, while overriding the diagnostic
Yes.
code,
Yes.
you also had to set the same values in the parent. You know,
Come again.
we had super
In the rule or in the fix?
in the in the rule.
Okay.
Yeah.
So this
Let's
is
check the first two.
this is a
Oh
rule.
yeah,
Yes.
this is what I'm. No, not
Okay, let me just bring
this.
let me bring a very simple rule that we can go through.
Okay.
Okay, yes.
So the length code actually have like the file length limit the same with in the super, right? You see, like they have the same
Yes,
values.
yes.
Yeah, we have to do that.
Yes. So this basically it's basically for you to register the diagnosis code, right? While this is part of the analysis rule. So the rule is meant to have its own name and description, right? And then hold the lint code. Eventually, this lint code is you are going to register it somewhere. Yes. So the point of that code that you saw there is because you have to reference the actual lint itself while you are trying to register the fix. So this is the rule, then get the lint code, then the fix to it. However, when you are defining the analysis rule itself, you have to override the things like name and description because, I mean, the analysis rule itself takes in name, description, and a state, right? So since we are extending it, we have to provide our own name, our description, and whatnot. Yeah.
Thank you.
So it's important for the name of the rule, right? When you are passing to the super class, it's important for it to match the name you've entered in the lint code itself, right? So this has to match this, else there'll be a problem. They have to match. Yeah, they have to match. So yeah.
All right. So are there any more questions? We're small here, so be interactive. Okay.
Like I told you, 1 hour is fine. All right, so if there are no questions, thank you. I remain myself, Samuel Abada.